Welcome back to We Learners Friends. So let's see what we learned in our previous lecture. We learned about the performance equation and performance measurement in our previous lecture. Here we have completed the part 1 of module 3, that is the basic structure of computer. We have completed functional units, basic operational concept. This is very important basic operational concept and compulsory question in VTU. And all this bus structure, processor clock, basic performance equation, clock rate and performance measurement will be asked for definitions. And here in this video we will be going to the part 2 of module 3, that is the machine instructions and programs. In this video we will be studying the memory location and addresses and memory operation if possible. I will be dividing this concept into two parts, part 1 and part 2. Part 1 I will be uploading in this video. And next, in this concept, address mode is compulsory question. I am repeating this again and again because this is a compulsory question. It is repeated in each sem. And also another important concept that you have to learn in part 2 is this addresses. Your byte addressability is very important concept. This will also be asked for 10 marks, and addressing mode is an important part in this important questions in this part 2. Let's get straight into the concept. Before that, I would like to request you all to please do subscribe, like and share to my YouTube channel. So let's get straight into the concept. Memory location and addresses is the first topic in our part 2. So what is a memory? I have in my previous video itself I have told you all about memory. Like, just compare the memory to your brain so that it will be easy. But in terms of computer, memory consists of many millions of storage cell. Storage cell is nothing but the flip flop. It not only consists of one or two, it consists of many millions of storage cell. I'm stressing in this part, like, many millions of storage cell is memory. So each cell can store a bit of information. Flip flop can this you will be studying about flip flop in the module 1 or module 2, that I will be covering in the later stages. Flip flop is one that stores either 0 or 1. So what is where flip flop will be present? It will be present in the memory, and or in other terms, memory consists of many millions of storage cells. Flip flop will store, that is, each cell can store a bit of information, either 1 or 0. So let's get into the next point. Each group of n bytes is referred to as word of information. So you all know that 8 bits here I have given here. 8 bits is called byte. This you will have been studied in the previous sense itself. So n bits is referred to as word, and n here refers to the word length. Word length can vary from 8 bit to 64 bits, right? Hope still here the concept is understandable to you all. And then let's see the next point what I have mentioned here. Next point is all about storing and accessing the item from the memory. I have already explained you all in the previous videos that data will be stored in the memory and it will be retrieved and operation will take place in the processor. So what happens while storing and retrieving the single item of information? To do that, there should be a distinct address location. For example, assume you have to go somewhere. Only if you know the location or place where you have to attend some webinar or some seminars, you have to go to a location. Only if you know the location, you can go and attend that. Similarly, only if you know the location where a particular item is stored, you can go and get that item from the memory and do the operation in the processor. I hope still your everything is clear. Accessing the memory to store or retrieve single item of information requires distinct address for each item and location. For example, your mother tells, like, keep this item in kitchen, keep this in this shelf, or something she tells. Only then you can place that item there, right? Without her telling, you will be confused where to place. So to place that item itself, you have a separate place, right? That is what they have mentioned in this point too. The next point, we will see what is in the last point. If 2k is equals to number of addressable location, then 2k addresses constitutes the address bar of the computer. It is very simple, don't get confused. 2k means like number of addressable location. For example, let's assume there is a plot. you're going to buy some plot and there is some plot. Okay, if there are 2k plots, means 2k plots they are available, so many plots are available, so that will constitute 2k addresses. If there are 2k location, means there is 2k addresses. That constitutes the address space of computer. That will tell like number of locations available in the computer. So many number of locations are available, you can store that item here. That simple. Here the example is given. Once you'll go through this example, it will be easy for you all to understand. All this is about the memory location and addresses. Here I'm just telling about the location, memory location. Addresses is about the byte address, which is very important, that I will be explaining in the part 2. Please continuously see my video so that it will be easy to go on with the concepts. Let's recap whatever we learned in this video. In this video, I have told you all about the memory. Memory means storage cells. Not only one or two million of storage cell. Storage cell is equals to flip flop. Flip flop will store either a single, either one or zero, that is a bit of information, and group of n bit is referred to as word of information, and n is word length, and word length can vary from 8 to 64 bit. A unit of 8 bit is called byte, and accessing the memory for storing and retrieving requires a distinct address where the item needs to be placed. If there are 2k addressable location in the memory, which means there are 2k addresses available, and in that location address spaces are available where I can place my item. All this thing that we learned here. And here 8 bit is called byte, and here I want you all to say what is nipple, like what is nipple called. This, let me know in the comment section, what, how many bits does a nipple constitute. This is a simple thing, please let me know in the comment section. So here I've told you all, no, like cell, each cell can each cell can store a bit of information. Here is the picture of that, figure of that. See, like first word will be stored here, second word and ninth word, and the last word will be stored. This is how a memory looks like. This is how a memory looks like. Okay, so if a word is to be stored in the memory, and the word, first word will be stored here and the last word will be stored here. And let's see how a 32 bit, that is a word, 32 bit is a word, and how it will be stored. Like 8 bits, 8 bits, 8 bits, 8 into 4 is 32 bit, and ASCII characters will be stored in these 8 bits. This is how a 32 bit word will look like. And if you all see here, this tag, this picture, y'all can see how a signed integer looks like. For what is a signed integer? If you all see this third 31st bit, that is from b1 to 31, B31, this is called MSB, which is also a sign bit. If the sign bit is 0, it signifies it is a positive number. If the sign bit is 1, it signifies it is a negative number. All this is an important figure that you have to remember, because in VTU, if you all write the figure and explain what it is, there is chances of getting more marks. Especially the figure you draw must be correct. Let's get into the next concept that we have to see here. Here the memory operation. There are two memory operation: load, which is also called read or fetch, and write. First we'll see what is load operation. Load operation transfer a copy of content of specific memory location to the processor. As I told you when I was explaining about the basic operational concept, data will be stored in the memory and it will be brought to the processor. So copy of content of specific memory location to the processor. The content which is there in the specific memory location, it can be 3000, 2000, any memory location, and I am bringing that content to the processor. This is called load operation. The memory content remain unchanged. We remember, we are only bringing the copy. We are not changing anything. We that contents content will remain unchanged in the memory. We are only bringing the copy. How the load operation takes place? There are 4 steps in which the load operation will take place. Let's see one by one. The processor sends the address of desired location to the memory. So whenever you want to send a courier to anyone or letter to anyone, you write the address on the letter and send it to the person, right? Or even a email you send, you will send it to the email address of specified person. Similarly, if you the processor, what it does, it sends the address of desired location to the memory. It tells the memory, in this location there is some data, you give me the data. It tells like this. You send the location and tells, in this location I have the required data, you send the data. This is what the processor tells to the memory, and the processor issues read signal to the memory to fetch data. After sending the address, processor will issue read signal, because it is reading the data from the memory, so it will issue the read signal to the memory to fetch the data. Next, what happens is memory reads the data stored at address. Okay, memory will respond now. It thinks, okay, processor requires this data and from this location, so it will read that data from that address. Memory sends the read data to the processor. Okay, it has now read the data. Now what it will do, so this is the data that processor require, let me send. It will send the data to the processor. Okay, I want you all to remember this steps to load operation like story. Now processor will send the address to the memory, and in this it will tell to the memory, in this location I need some data, you send that, and it will issue the read signal. So what does the memory do? Okay, processor requires this, so what it will do, it will fetch the data from that address and send to the processor. Simple story, remember in a way of story. Okay, now let's see what happens in the store operation. Before that, let's see what is store operation. So I have already told in my previous video that operation will takes place in the processor. In processor, in ALU, certain operation will take place, and the result can be stored in the registers of the processor, general purpose register, or it can store in the memory. It depends upon the operation. So if the result needs to be stored in the memory, how it will store, that is how the store operation, we will see that in detail. Store operation transfers the information from the register of specified memory location, from the register to the specified memory location. So whenever an ALU operation takes place, assume this is ALU, and this is the general purpose register. In ALU, certain operation takes place. After that operation gets over, the result will be stored in the general purpose register. So if I require that to the memory, I require that result in my memory to be stored in the memory. From register to the memory I will send, and in some location of memory I will store that result. This will destroy the original content of memory location. So I am sending a new data and telling the memory to store in that location. Whatever the content that was previously in that location will get deleted, obviously will get destroyed. So let's see whatever happens in store operation. So what happens in store operation? Obviously something that opposite to the load operation will takes place. Steps for the store operation are: processor sends the address of the memory location where it wants to store the data. Now processor, similar to the load operation, what this processor will do is that it will send the address and tell, I want to store the data. In previous load operation, he said I want the data, and in this store operation it will tell you store the data, and processor issues write signal to the memory to store the data. In previous, it issued the read signal because it wanted to fetch the data. Here it want to store the data, so it is issuing the write signal, it is writing that. Okay, content of memory, content of register is written into the specified memory location. So whatever was in this general purpose register, no, so that will be written in the specified memory location. Processor initially sent some location in to the memory, and whatever the content was there in that memory location got deleted. If there was nothing, nothing happens, and then processor issues the write signal and tells the memory to write there, and whatever the content was there in the general purpose register got stored into the memory. Just simple, it is very simple and easy concept to remember. Hope you all understood this concept. If any doubt, please let me know in the comment section. Thank you.